In this lesson, we're going to focus on inscribed angles, okay? And before we talk about what inscribed angles are, we're going to review what a central angle is. So recall that if you have a central angle, the vertex is going to lie right on the center of the circle. And we talked about this last time, that point A right there, it is the center and it is the vertex of your central angle at the same time. Okay, it's the center of the circle and it's the vertex for your central angle. An inscribed angle is now going to be some angle where the vertex is going to lie on the circumference of the circle. Okay, so now the vertex is not on the center. Instead, our vertex is right on the boundary or the circumference of the circle. And that point B could be anywhere on the boundary of the circle here, okay? We're going to think of points A and C when we talk about this next part. So points A and C, and also points B and C here that lie on the circle, all of those points we're going to refer to as endpoints, okay? So those are all the endpoints. So in this next theorem, what is the relationship going to be between an inscribed angle, a central angle, and what's called the intercepted arc? Okay, so the intercepted arc is just some arc that we've highlighted in blue here, and it's between points A and B. Okay, so if a central angle and inscribed angle, if they share the same endpoints, we see both this green central angle and this red inscribed angle, they share the same endpoints there, okay? They also share the same intercepted arc. For both the central angle and the inscribed angle, they both have this arc. Then the central angle is double the measure of the inscribed angle. So let's put some numbers to this. Let's say, for example, that our central angle was 60 degrees, okay? Well, how much would our intercepted arc be? So from the very last lesson, we know that the central angle is going to be the exact same thing as the arc, okay? So this would also be 60 degrees. And then the inscribed angle, well, if the central angle is double whatever the inscribed angle is, this is going to be half, okay? So then this should be 30 degrees, okay? Let's try this out again. So let's say that the central angle was 40 degrees. That means the intercepted arc is 40 degrees. How many degrees is the inscribed angle? 20, so it's half of that. So that's the relationship. It's kind of like the radius and diameter relationship, where it's either half or double depending on which one that you're looking at. Let's try a couple more examples. So again, one more time, if this was 100, just like this would be 100, then this would be 50, okay? So we could also go the other way around with this. So instead, if this was, let's say 25 degrees, if our inscribed angle is 25 degrees, how much is our central angle? Okay, well, it should be double, so that is 50, okay? And our intercepted arc is also 50. One more little example. So if this was 2 degrees, then this would be 4 degrees. That means this would be 4 degrees as well, okay? So hopefully you can see the relationship that's going on there between all of those angles, between both of those angles, and between the intercepted arc, okay? So now I'm going to encourage you to pause the video right now and try out these problems, okay, on your own. Unpause the video when you feel like you have an answer. So we're going to find the measure of the indicated arc or angle, okay? So either we're finding an arc or an angle. So this one we're finding the measure of an angle. So it's angle PQR, and we'll highlight that here. So PQR. So that angle would be inscribed. hopefully you should have put 45 degrees, because I see that this is the central angle here, and this should end up being half of whatever that central angle is, okay? So the measure of PQR is 45 degrees, okay? All right, next one. So this one, we're finding the measure of an arc, because we can see that arc symbol over the top of the letters. So it's arc STQ, and it's highlighted here, blue. I'll just make it in green. So STQ there. Notice that it uses 3 letters, so this is a major arc, or it might be a semicircle. So let's see. This angle right here, SRQ, is this an inscribed angle or a central angle? So this is definitely an inscribed angle because its vertex is on the boundary of the circle, okay? So I see right now that this is 90 degrees. What then is the arc? Okay, so the arc, just like the central angle, is going to be double. So this should be 180 degrees. So yep, it looks like it's a semicircle. So the measure of angle the measure of arc STQ is 180 degrees. There. Next one we have in angles, so angle NMP, which is just this angle here. And then this 100 degrees is talking about this intercepted arc, NP. So that arc is 100 degrees. So if you're thinking that this is 50 degrees, you are totally correct. Okay, so that should be half of what my intercepted arc is. So yeah, 50 degrees there. All right, next one. So this one we're finding an arc again. So arc ZWX. So it definitely looks like this is more than a semicircle now. This would definitely be a major arc. And in this one we're told that this inscribed angle is 115. So what then should this arc be? Okay. Well, it looks like it should be 230 degrees. Okay, it's going to be double whatever my inscribed angle is. So that arc is 230 degrees. Okay, last couple of problems. So the measure of arc DM. So that's from here all the way to here. Okay. So this picture looks a little bit different than stuff that we've been used to looking at, but the same things are still going to apply. So this angle right here is our inscribed angle. Okay. Its vertex is on the boundary of the circle. So if this is 16 degrees, that's our inscribed angle, what then is the arc, the intercepted arc? Okay, so it should be 32 degrees. Okay. So there's my inscribed angle. The arc should be double of what that angle is. And then lastly, angle NHT. Okay. So NHT, this angle is definitely inscribed. So you see that the vertex is on the boundary of the circle. So right now, that 36 degrees is describing that intercepted arc right there. So if this is 36, I just think, okay, what's half of 36? And that's my inscribed angle. So that should be 18 degrees. Okay. So this is equal to 18 degrees, and this is equal to 32 degrees. Okay. Okay. Another theorem that we'll look at is that if we have inscribed angles and they share the same endpoints, okay, then their measures are congruent. So check this out. If you look at this picture over here, we have 3 different inscribed angles, okay? So again, all of their vertices are on the boundary of the circle. That means that they're inscribed, and they're all connected to these same 2 endpoints here and here. Okay, so if this ever happens where they're connected to the same endpoints and in their inscribed angles, they're all going to be the same degree. Okay, So we can kind of reiterate this if we look at this animation over here. Okay, so what do you think is going to happen if I take this point P and move it around the circle? What's going to happen? Okay, so it's going to stay exactly the same. No matter where I move this around, as long as it's below B and A, so like if I move it above, that's when it would change, okay? But as long as it's below B and A, then it's not going to change. And of course I can move the endpoints as I want to, and then below that it would continue to remain the same. So with that idea, again, pause the video and see if you can find the answer to the following problems. All right, so now we're going to solve for the indicated angle here. So the measure of angle GFH. GFH, so that's this angle here. So notice that both angle GFH and GEH, they're both inscribed. They both share these endpoints, okay? So that means they're both going to be exactly the same degrees, okay? So this is also 75 degrees because they share the same endpoints. Okay, let's look at another one. So measure of angle ACD. So ACD. So it almost looks like a little bow tie here inside of the circle, but the things that I want you to focus on are that this angle, it's definitely inscribed. There, its vertex is on the boundary of the circle. And then we have this other angle here, was also inscribed. And it looks like both of them share the same endpoints, A and D. Those are both the same endpoints. So since I have all of that together, that green angle should be 44 degrees as well. The exact same thing. All right, and then the last one for this is the measure of angle AEB and ACB. So let's focus on AEB first. So AEB is the green angle here. Notice that all of these are inscribed, so I know that all of these should be the same thing. The green, purple, and red ones, all the same measure. I just don't know what that is yet. So kind of tying in from the stuff that we learned on the last page, if this is my intercepted arc, and this is my inscribed angle, what's the relationship between those two? Okay, so that inscribed angle should be half of the intercepted arc, so this should be 30 degrees, meaning that the rest of these angles are all going to be 30 degrees as well, okay? So both AEB and ACB are 30 degrees. Okay, and the last theorem that we'll look at, there's no practice problems for this one, but it just says if a triangle is inscribed, so if a triangle is inscribed inside a circle, so that one of its sides is the diameter, okay, so we see that like AOC, that's the diameter there. So there's a triangle, one of its sides is the diameter. Then the triangle is right, okay? So I can see kind of this cool animation where if I move this point B around on this triangle, and if one of the sides is the diameter, it's always going to be a right triangle, no matter what. And this is just kind of showing you what it looks like in slow motion.